Okay, let's continue with sample exam 2, number 5 in Chem 11. This one is a question about gases, and it talks about that you start with a gas at 25 psi, and the question is what happens if you reduce the pressure to 6.25 psi to the effusion rate, okay? And you're keeping, in this case, volumes and number of moles constant. So for this question, you're going to need to remember the fact that effusion rate is the same as the root mean square velocity, or URMS, of the gas, given by this equation right here, 3RT over m, where m is molar mass and T is temperature in Kelvin, R is the gas constant. And so what we want to know is how would that URMS change as we change pressure from 25 to 6.25. Of course, one of the part that's a little difficult here is how do we solve a problem where pressure is being changed, but our equation doesn't contain any pressure. Remember that PV is equal to nRT, so that means that RT is equal to PV over N. And so what you can do is you can rewrite your URMS instead of 3RT over M, you can write it as 3PV over N over M, okay? And so now we can see how change in pressure can affect the speed, because pressure is now written as part of that equation. How do we solve the problem? Well, this is one of those situations where there's two conditions. Condition 1, we can say we have pressure 1, which of course is our 25 psi, and then we have volume 1. We don't know what that is, but we can just call it V1, N1, number of moles 1, and then M1, which is the molar mass in condition 1. And then we have condition 2, where we have P2, which now is 6.25 psi. And if you look at that number carefully, compare that to the 25, it's actually just a quarter of P1. Quarter of 25 is 6.25. And then we have V2, but we were told in this case that the volume doesn't change, and the number of moles also doesn't change. So that means that V2 is just equal to V1, and N2 is equal to N1. And since we're talking about the same gas, molar mass 2, M2, is equal to molar mass 1. Basically, what you need to do is write an equation that compares the speed at condition 2 to speed at condition 1. In condition 2, we have the speed being equal to 3p2 v2 over n2 over m2, right? And then in condition 1, we have the speed being equal to 3p1 v1 over n1 over m1. I can just take the square root of the whole expression, numerator, denominator, and write it as 3. P2 I can replace with a quarter of P1 as we found here. So 3 times P1 over 4, and then V2 is just equal to V1, N2 is just equal to N1, M2, molar mass 2, is just equal to molar mass 1. So that's the numerator. The denominator is just 3P1 V1 over N1 over M1. The reason I'm writing it this way, of course, is because then it allows us to easily see that some of these variables can be canceled. So our volumes go away, our number of moles go away, our M1, molar mass, go away, and you can see even the P1 and the 3 disappear. So when we reduce everything down, it ends up just being the square root of 1 over 4, which is of course just 1/2. So what that tells us is that U2 is 1/2 of U1. So in other words, the speed or the effusion rate at condition 2 is going to be half of the speed at condition 1. So the effusion rate in this case has decreased by a factor of 2, okay, which is answer A right here.